with 0.1 capital M sodium hydroxide solution F. So this one is 0.1 capital M sodium hydroxide called solution F. Solution G is made by dissolving 23.46 grams of a diabasic acid in 250 centimeters cube of distilled water. Very important. Kuna kitu hapa nataka ujue. I want you to know what is a diabasic acid. We have monobasic acid. Examples of monobasic acid is HCl. It has got only one hydrogen. Monobasic. Nitric acid. Monobasic. Diabasic is an acid like sulfuric acid. So this acid here is an example of sulfuric acid. So if you know how to write equation with bases using sulfuric acid, this one is not going to give you a problem. So this diabasic acid was dissolved, 23.4 grams of diabasic acid was dissolved in 250. Very important that this is the mass in 250, not in 1,000, but this mass is in 250 centimeters cube. So you are required to determine to dilute solution G, standardize that. So we are going to dilute this solution G. Procedure 1. Using a measuring cylinder, measure 20 centimeters cube of solution G and transfer it into a beaker. Measure 80 centimeters cube of distilled water and add it to the 20 centimeters cube of solution G in a beaker. Label the solution H. Understanding the procedure or whatever you are doing is very important. We are taking 20 solution G, add 80 centimeters cube water, distilled water, and forming 100 centimeters cube solution H, because 20 plus 80 is 100 H. So this H we are forming here, the total volume is 100 centimeters cube, kwa sababu ni 20 G plus 80 centimeters cube of distilled water. And what is H? H is the diabasic acid G. Remember that. H is a diabasic acid G, but diluted now. Procedure 2. Place solution H in a purate. Pipette 25 centimeters cube of solution F into a 250 centimeters cube conical flask. Add 2 to 3 drops of phenolphthalein indicator and titrate with solution H. Record the results. So the results was recorded and we have 14. So let us complete the table. Because we have been given to one decimal place, we will take our initial to be 0.0, 0.0, 0.0. You subtract here, it is going to be 14.1, 13.9, 14.2. So calculate the average volume of solution H. This is the solution of H that was used. So the average is you add this plus this divided by 3. So our average is 14.10 centimeters cube. Determine the number of moles of solution F in 25. F is sodium hydroxide. F is sodium hydroxide. We have the molarity. Molarity is the number of moles in 1,000. This capital M stands for molarity, and the molarity is the number of moles in 1,000 centimeters cube. So we know that is 0.1 solution F, 0.1 moles actually, moles of solution F are contained in 1,000 centimeters cube. F. What was the volume we used? We have been given it is 25, so we will ask 25 centimeters cube F will contain how many? 25 times 0.1 divided by 1000. This one will give us 0.0025 moles. So this is the number of moles of sodium hydroxide that reacted with H. Determine the number of moles of acid in solution H in the average volume. Remember this H, we don't know anything about H at all. We only know about the volume. It will be 100. So for us to know some information about H, we must write the reaction between H and F. So the reaction F is sodium hydroxide. So it reacted with H, which is H2MO6. This one here. I told you this one is like sulfuric acid, so you write the equation the way you could have written using sulfuric acid. So you will have sodium sulfate. Instead of sulfate, you write MO6 plus water. It is a salt plus water reaction because this is neutralization. But since sodium here is 2, you balance by writing 2 here, and that is it. The volume for this one is 14.1. The volume for this one is 25. Na tuko na moles yake. The moles of this one is 0.0025. So we are asking the moles of H. This is H in the average. So what was the number? So because the ratio here now you can see the mole ratio of sodium to H2MO6 is 2 to 1. Fine. So meaning that the number of moles of the H acid here is going to be a half. So we are going to, this one is equal to 0.0025. You ask 1 will be what? This one. That is 1 times 0.0025 divided by 2. So the moles of the acid that was used is 0.00125. That is the number of moles of H. Sawa? So it is important to kuandika equation, ujue kuandika equation na kubalance. If you don't know that, then it becomes very difficult. Determine the number of moles of acid in 100 centimeters cube of the solution H. Now we know the number of moles of H in 25. Is it in 25? In 14. Because H, the average volume is 14. H, the average is 14. So this moles is the moles of H in 14 centimeters cube. So 14.10 centimeters cube contains 0.00125. We will simply ask what would be 100 centimeters cube. H will contain what? So we simply, this other 100 times 0.00125 we divide by 14.1. That one gives us 0.00865 moles. This is the number of moles in 100 solution H. 100. Determine the number of moles in the acid in 20 in the acid. The question starts here. Determine the number of moles in acid in 25 of the acid in 25 centimeters cube solution G. So you must know what happened. We measured 25 centimeters cube of solution G, diluted it to 100 centimeters cube solution H, meaning that the number of moles in 100 centimeters cube solution H will be exactly the number of moles in 20 centimeters cube solution G, the original. So number of moles in 100 centimeters cube solution H will be equal to the number of moles in 20 centimeters cube solution G. So moles of 20 centimeters cube G will be equal to 0.008865 moles. This one here, because this is the number of moles of H in 100. Number of moles in 250 of solution G. That's very simple now that we know the number of moles of G in 20. So 20 centimeters cube G contains 0.008865 moles. Right? So we will ask 250 centimeters cube G will contain 250 times 0.008865. We divide by 20. And this one gives us 0.1108 moles. So this is the number of moles in 250 G. Calculate the molar mass of acid. The molar mass. Molar mass is the same as RFM. Fine. So there is two ways we can do this. So we can use method 1. We know the number of moles in 250. 250 centimeters cube contains 0.1108 moles, right? And what was the mass in here? We were given the mass in 250. So the mass 23.46, this was the mass also in 250, and it contains 0.1108 moles. So 1 mole will contain what? So that is 1 times 23.46 divided by 0.1108. This one gives us 211.7, and that is the mass in grams per liter. You can simply say RFM is equal to mass over moles. That's what I have done. Method 1 is RFM is equal to mass, this is mass of RFM in 250. So, or method 2, we can get the mass in a liter. So 23.46 grams are in 250 centimeters cube. 1000 a liter centimeters cube will contain how many? That is 1000 times 23.46 divided by 250, and this one will give us 93.84 grams per liter. That is the mass in grams per liter. But we know that molarity is equal to mass in grams per liter divided by RFM, meaning that RFM is equal to mass in grams per liter divided by molarity, right? So molarity will be, you ask if this one, if this is the number of moles in 250, what will be the number of moles in 1,000? 1,000, it will give you 0.4433. So that is 93.84 divided by 0.4433, and that one will be 211.1.71. Determine the mass of M in the formula this, given that H is equal to this and that. So, but we have the RFM. RFM, which is the molar mass, is equal to, we can round off this one to 212. We can round off this 212. So, H2MO6 will be equal to 212. To 212. H is 1, so 1 times 2 plus M plus 16 times 6, the answer is 12 to 12. So this is 2 plus M plus 96 will give us 212. So we can like terms together. So M is equal to 212 minus 2 minus 96. So M is equal to 212 minus 98. So M is equal to 114. 0.1 molar sodium hydroxide solution B, 10 grams of a mixture of sodium hydrogen carbonate and sodium chloride per liter solution, solution C. You are required to determine the molarity of A, the percentage purity by mass of sodium hydrogen carbonate. So from here, this statement 0.1 molar sodium hydrogen, it means 0.1 molar implies 0.1 moles in 1,000 centimeters cube solution B. That's what it means. 10 grams of the mixture. So this mixture, it is 10 grams per liter. So this mixture, the mixture is 10 grams in 1 liter. Very important. Procedure 1. Fill the purate with solution A. So in the purate, we have A, which is HCl. Pipette 25 centimeters cube of 0.1 molar sodium hydroxide solution B into a clean conical flask. Add 2 drops of methyl orange indicator. Titrate with this and then record on the table. So it is important for you to understand what's happening in the procedure. So HCl is reacting with sodium hydroxide. So that this is a neutralization reaction. So what is in the burette? The burette contains HCl. So the volume we have written in the table here, it is the volume for HCl solution A. This is HCl. It is important for you to note that, so that you avoid being confused. So calculate the average. The average, you just add 13.5 plus 13.6 plus 13.5 divided by 3. The average is always given to 2 decimal places, that is 13.53 centimeters cube. Average is given 2 decimal places. Calculate the number of moles of hydrochloric acid solution A that reacted with 25 centimeters cube of sodium hydroxide solution B. Ukiangalia hapa nyuma, we don't have any information about the solution A. You see that? The only information now we have is that 13.53 solution A, HCl, reacted with 25. That's the only thing we know. So for us to know more information about A, we have to write the equation, which is now sodium hydroxide reacting with HCl. And this one forms sodium chloride plus water. The equation is balanced already because the ratio is 1:1. Sodium hydroxide used, it is 25 centimeters. The molarity here is 0.1, capital M. The only thing we know here is that we used 13.53, and we are asking to get the number of moles of this solution. This is solution A, and this is solution B. We are asking to get the number of moles of solution A. So for us to get that, first we need to know to get the number of moles of sodium hydroxide that reacted with this, because that's what we are sure. So we know that 0.1 is the number of moles in 1000 centimeters cube of solution B. We will ask 25 centimeters cube solution B that reacted with A will contain how many moles? That is 25 times 0.1, we divide by 1000, and this one will give us 0.0025 moles. So this is the number of moles of solution B. So, but the mole ratio is 1:1, meaning that the number of moles of sodium hydroxide that reacted with HCl are equal. Therefore, moles of 25 centimeters, the number of moles of 13.53 centimeters cube HCl is 0.0025 moles, because the mole ratio is calculate the concentration of solution A in moles per liter. Concentration in moles per liter simply means calculate the molarity of solution A. Calculate the molarity of solution A. And what is molarity? You should always know that molarity, you don't have to write this, but because I'm teaching you, that's why I'm writing this one. You don't have to write this. Molarity is the number of moles in 1000 centimeters cube of a solution, 1 liter. So you need to know that. Therefore, whenever you hear the word concentration in moles per liter, it simply means calculate the molarity. Fine. So molarity is the number of moles in 1000. Once you know that the divination, now this one is easier. We have the number of moles of A in the volume that was used. So 13.53 moles centimeters cube has got how many moles? 0.0025. Solution A. Molarity is in 1000, so we will ask 1000 centimeters cube per liter of solution A will contain which number of moles? That is now 1000 times 0.0025 divided by 13.53, and this one will give us 0.1848 capital M. That is molarity, or you can as well write 0.1848 mole per liter. That one is acceptable. Pipette 25, that's procedure 2. Pipette 25 centimeters cube of solution C into a conical flask. Titrate with solution A using 3 drops of methyl orange indicator. Record the results in the table below. So this is our table. I have already filled the table. Always use 1 decimal place, or you can use 2 decimal place consistently. Calculate the average. Now, first understand what's happening here now. Solution A, which is HCl, is reacting with mixture C. Remember, the mixture C was sodium hydrogen carbonate mixed with sodium chloride. So the acid A will just react with sodium hydrogen carbonate because sodium chloride is a salt. So it is the acid will not react with a salt. The acid is going to react only with sodium hydrogen carbonate. Sodium chloride will remain as an impurity. So mixed, we are going to write the ionic equation for the reaction taking place between solution A and the mixture C. But mixture C we know is sodium hydrogen carbonate mixed with sodium chloride. So A is HCl. HCl will only react with sodium hydrogen carbonate. So the reaction that will take place, it is sodium hydrogen carbonate reacting with A, HCl, to form sodium chloride plus water plus CO2. This is a gas, this is liquid, this is aqueous, aqueous, aqueous. Fine, but we were told to write the ionic equation. We write the ions that forms the liquid and the gas only, and not those that makes an aqueous solution. So here, it is from here we will have hydrogen ions, hydrogen carbonate, which will react with HCl, hydrogen ions from HCl to form water, which is in liquid form, plus CO2, which is in gaseous form. And this is the ionic equation. So you write the aqueous, liquid, gas. This is the ionic. So this is what you are required to write. I have simply written step by step so that you can understand what to. Lakini kama hujaelewa vizuri mambo na ionic equations, there is a video you can check on my channel. You just search ionic equation reactions and you will get the video. Calculate the molarity of sodium hydrogen carbonate in moles per liter. So we have been asked to calculate the molarity of sodium hydrogen carbonate. So sodium hydrogen carbonate is reacting with HCl here. But we know the molarity of this and we know the volume of A that reacted. Now if we get the number of moles of HCl, we will automatically get the number of moles of sodium hydrogen carbonate because the ratio is 1:1. Fine. So we start by getting the number of moles that reacted, the number of moles of HCl. So 1,000 centimeters cube of solution A, molarity, this one contains 0.1848 moles. Where did I get this one? In our previous, we have a molarity of A here. This is the molarity of A. So that's what I have used. So if 1,000 centimeters of A contains these moles, what about the A that was used here? 12. 12.5 centimeters cube will contain how many moles? So that is 12.5 times 0.1848. You divide it by 1,000. Now this one will give us the number of moles, and this one is 0.0023097 moles. So this is the number of moles of HCl A that was used. But since the mole ratio is 1:1, it means moles of sodium hydrogen carbonate will be equal, which is 0.00230 0. Okay, let me write here, would be 0.0002309.7. This is the number of moles of sodium hydrogen carbonate because the ratio is 1:1. But we were asked to calculate the molarity. Molarity is the number of moles per liter. So this is the number of moles of hydrogen carbonate. Remember, we pipetted 25. So the volume of hydrogen carbonate at solution C is 25. So this is the number of moles in 25. So you ask 25 centimeters cube is 0.0002397. What about 1,000? Because molarity is the number of moles in 1,000. Will be what? So you cross multiply like that, and we will get the molarity will be 0.0. Let me use my calc first. 0.09239 molar. That is the molarity of. The next question is calculate the mass of sodium hydrogen carbonate in moles per liter. Mass in moles per liter. So we have been given that sodium is equal to 23, oxygen is equal to 16. So this is what was missing. Carbon is equal to this. So how do you get the moles mass in moles per liter? Mass in grams per liter. I have given this triangle most of the time. So if molarity is equal to mass in grams per liter divided by RFM. So if I want RFM will be mass in grams per liter divided by molarity. We have the molarity of solution C, this one. We have the RFM from here. So we write the sodium hydrogen carbonate is written at NaHCO3. So this is 23 plus 1 plus 12 plus 16 times 3, and it will give us a total of 84. Fine. And that is the RFM. So from this triangle, we know that we are looking for mass in grams per liter. Mass in grams per liter, mass in grams per liter is equal to molarity times RFM. Molarity times RFM. Molarity we have here 0.09239 times RFM, which is 84. And this one will give us 7.76 grams per liter. So that is 161 grams per liter. So this is the mass of only sodium hydrogen carbonate. Next question, calculate the mass of sodium chloride in the mixture. Our mixture, remember, ilikuwa na sodium hydrogen carbonate plus sodium chloride, and the total mass was 10 grams per liter. But sodium hydrogen carbonate only has got 7 point that. So to get sodium chloride alone, it is 10 grams per liter minus 7.761 grams per liter of sodium hydrogen carbonate, and this one will give us 2.239 grams per liter, and this is only sodium chloride, which is an impurity. Calculate the percentage purity of sodium hydrogen carbonate. Percentage purity is equal to the mass over original mass times 100. So the mass of sodium hydrogen carbonate, it is 7.761 divided by the total mass, which is 10 times 100. And this one will give us 77.61%. Kama ulikuwa umeulizwa the percentage purity of chlorine or sodium chloride, unaweka mass yake, which is 2.239 divided by 10 times 100. And you are done. Thank you very much. Share this video to as many people as you can.